Alright, folks, today we are continuing on with question 3 of NJ 2024 promo paper. Question 3 is a modulus involving numerous topics. It is a 5-mark question, but as you can see, they've combined more than one topic of H2 math together. I believe you can read the question for yourself, so I'm going to jump in to the next slide because I need to talk a bit about modulus functions. So when you're talking about modulus functions, right, I would like to inform you and I would like to alert you that you need to show your full awareness, and the marker wants to know that you are aware that the definition of a modulus is a piecewise function. Why is the definition of modulus a piecewise function? Because the modulus function has two rules. Yeah, you know a function has a rule and domain. The modulus function has two rules based on the domain of the modulus function itself. Whether is it more than equals to 0 or is it less than 0. And as you can see, modulus function is always appearing in your H2 math exams because it appears in so many topics. Just read the list alone. It appears in all the topics except for whatever I've stated down here. And if you even try to calculate, right, you'll notice that it's at least like taking up a damn huge 2/3 of the syllabus. Are you aware of that? So please go and learn your modulus. If you do not know your modulus, please come and find me. I am Vectors Lee. Your modulus function, you must know. Otherwise, if you go for the exam without knowing modulus function, I can assure you, you are doomed. I say again, if you do not know your modulus function, you are doomed. And you can kiss your A and B goodbye. So please know your modulus function very well and what the piecewise function really means. Okay, so we were to see this question going back here. Part A is of course asking to sketch a modulus graph, right? So I can tell you that if let's say you need some help with sketching modulus graphs, then maybe the symmetry is going to be like a it's going to be like a helping hand for you because later on, right, you just need to know that the modulus graph is a reflection, right? Because it's the whole thing the whole thing is a modulus, right? So it's just going to be a reflection about the x-axis. And please take note that the modulus graph should always be lying above the x-axis, right? Okay, so without further ado, I'm going to go to the answers for here, right? I'm going to go to the answers for here. Actually, this is quite a simple graph simply because the question did not ask you to go and state all the features. But if let's say the question did not specify that it needed to state the features, what I need to do is that I need to sketch all the features of the graph. Remember my acronym, always give Singapore infinite opportunities to emerge stronger. So I'm going to talk about asymptotes, then graph, and I'm going to use my GC to determine the shape before moving on to the line of symmetry. And after the line of symmetry, I'm going to talk about the intercepts. And of course, please label the origin. After labeling the origin, then please, of course, label your turning points. Like you don't necessarily have to do a demonstration because you can use a GC, the question never say exact. And then for endpoints, right? For endpoints, right? The endpoints, right? For endpoints, this is only for functions. Endpoints is when the question, especially a functions question, restricts the domain of the graph. But I'll elaborate more on that in the functions questions, right? So then, of course, please remember to sketch and label the equation of the curve. But because in this case, right, the question only asks for the coordinates of points where the curve cuts the axis, which means that in other words, they are asking for the axial intercepts. So the moment that you have shown that you have clearly labeled the axial intercepts, you are going to get your first mark. Your second mark is, of course, the shape plus the labeling equation of the curve. And of course, please label your origin, right? For this question, it so turns out coincidental that the y-intercept is actually the origin. So it's also the y-intercept and the x-intercept. But this graph has two intercepts. It is at the first intercept is at the origin for x-intercept, and the second x-intercept is at when x is equals to k, so it's the point of coordinates k, 0. Okay. Then some of you, if you were to be looking at my graph, right? If you have ever tried to use the GC, right? You will notice that at the origin, when the graph passes through the origin, it is in the original graph, right? It's actually a turning point. Because this is a turning point, right? It is a turning point. So the gradient at the origin should be 0. And when the gradient at the origin is 0, you can draw a smooth curve. But, ladies and gentlemen, at k, 0, when the x is equal to k, that point is not a turning point. So the reflection needs to be shown very clearly. This in mathematics is actually called a kink point. K-I-N-K. Kink point. Or in other words, it's called a sharp point. But let me spell the word kink for you. Please give me a moment. Alright, so I apologize for the messy handwriting, but this is how you spell the word kink point. Kink point in mathematics means the sharp point. And please note that the marker expects to see it especially when it's a modulus graph without a turning point, because they want to show a reflection, like a mirror image. Okay? But this is not the main point I want to talk about. The main point that I want to talk about is this thing called the definite integral of modulus. Definite integral of modulus is a very common application, so I want you to know this at the bottom of your hands by the end of today. At the end of this video, I want you to ask yourself, search your soul, search your mind, search your heart. Are you fully aware of how to go and break down the definition of modulus? Are you aware that careless mistakes for the definite integrals cannot be made because it is not worth it? So in this video, I'm going to teach you how to do so. Now, a lot of students, they have this bad habit. The bad habit that they have is that they like to jump the gun. Like, oh, okay, I see. Oh, I want to integrate well, this modulus function from 0 to 2k. What they do is, oh, okay, just jump over the bandwagon. So jump the gun law. I see this, I just straight away integrate law. No, no such thing, ladies and gentlemen. You need to check for the modulus based on the piecewise function. You need to account for the domain, right? Like in this case, okay, in this case, 0 to 2k. How do I even know the first place, right? Does this modulus function need to be split into two parts, or can it just be maintained as one part? It can only be maintained as one part, right? If let's say the upper bound and the lower bound, right? It lies within the domain of one particular part of the modulus function. Like for let's say, oh, okay, x squared times x minus k. Now, if let's say I have to solve the inequality x more than equals to k. So that means if let's say the upper bound is very huge, and then the lower bound is like also x more than k. So that is when you can very safely do the integration for x squared times x minus k without even having to break down the modulus. But in this case, unfortunately, I do not know. So let's say, ladies and gentlemen, if your math is like, let's say you all don't know, you all are very overwhelmed, okay? What you do is you do things systematically, resolve the modulus. Now, ladies and gentlemen, let's recall hardcore content. I say again, this is hardcore content. Definition of modulus is a piecewise function. If I mod fx, it's going to be mod fx for the domain of fx more than equals to 0. And in this case, the fx is x squared times x minus k. And same thing, right? If let's say if the function is less than 0, then the modulus is going to be a negative of the function. Why so? Because negative of a negative function, negative give you positive. And that is how the modulus is able to help convert everything into a positive function, right? So, okay, so I'm going to show you very properly. Ladies and gentlemen, open your eyes, open your ears, open your hearts, open your minds. Look at this. I'm now going to break down the modulus, okay? So, see, the first one, okay? The first one. This modulus is equal to x squared times x minus k if this is more than 0. So, okay, now what I'm going to do is I'm going to solve this inequality. I'm going to ask myself, what is x? Because why? The upper and lower limits are all in terms of x. They're all x values. So I'm going to ask myself, for which domain is it going to render the modulus more than equals to 0, right? Is it going to render this function more than equals to 0, right? Then I can apply the original definition of modulus, right? So solving this inequality, I'm going to say that, oh, okay, I'm going to use that, your x squared is more than 0 for all real values of x. So this one means that it's all real values of x. Please take note of this notation over here because it's very, very, very common, right? Then, so by the time I solve this inequality, it's going to be x minus k more than equals to 0. And then by bringing the k over to the right-hand side, I'm going to get x more than equals to k. So far, so good, yeah? Then for the left-hand side, for the other piecewise, right? For the other piecewise, right? If let's say is this function, right, x squared times x minus k is less than 0, what I'm going to do is going to multiply by negative, 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 positive, right? So I'm going to second thing, I'm going to solve the inequality. It still doesn't change. X squared is always more than equals to 0, regardless of what circumstance, for all real values of x, right? So I'm going to solve the inequality again. So since x squared is more than 0, more than equals 0 for all real values of x, I'm going to say that x minus k is less than 0, and hence I found out that x is less than k. So ladies and gentlemen, I have these two very big underlying modulus functions for me. These two very, very, very nice underlying inequalities for me. Okay? This inequality is solved just from the definition of modulus alone. So this is how you actually perform the modulus systematically. So, ladies and gentlemen, what is my purpose of solving this inequality? My purpose of solving this inequality is to notice that this inequality, when solved, right, is actually there's an overlap between the domain that I want to find. And because there's an overlap between there's an overlap with the upper bound and the lower bound of the definite integral I want to find, right? So because the upper bound is 2k, the lower bound is 0. So the k is like halfway through, right? So, ladies and gentlemen, now what I'm going to do is I'm going to split this into two parts. Is it positive or is it negative? Right? So, should I add? Should I add a minus sign? I don't think negative because I don't confuse people. So, okay, because when x is less than k, right, it's going to be adding a negative sign. So because I add a negative sign, what I'm going to do is I'm going to come up with the first part. This is the first part, okay? Sorry, yeah. Let me highlight to you. This is the first part, right? This is the first part of the modulus function. Then, for x more than equals to k, there's still a second part where x is more than equals to k. The second part where x more than equals to k is going to be this over here, right? It's going to be this over here. So what is the learning point? The learning point is that I do not want you to go and jump the gun, to go and anyhow go and just plonk in 2k and 0. Because if you ever tried doing that, when x is less than k, you notice that since the graph lies below the x-axis, right? Since the graph lies, the original graph of x squared, x minus k, without the modulus, lies below the x-axis, right? It is going to result in a negative integral and hence an inaccurate answer. So if you don't know, please take note of this important learning point. I expect that all your modulus questions involving definite integrals, you will do this from now on as a check. That's how I can play safe. I can guarantee you, if you know this, the Cambridge marker is going to give you at least 1 to 2 marks in the exams. Okay? So without further ado, I'm just going to go and perform the integration directly. So to perform the integration, you notice I need to expand it because I don't have any f prime and f rated things. I don't have any rated f prime and f. So I was going to perform the definite integral. Then from here, what I'm going to get is I'm going to get this part over here. I'm going to get this definite integral. Then all I need to go and calculate the definite integral. So, ladies and gentlemen, I would like to mention that if let's say this part can get overwhelming, so if let's say you all want to make careless mistake with the signs, you all would make careless mistake with the signs like positive or negative, then please like try to go and put some brackets. Then later on you can just resolve the brackets. And later I'll just simplify my answer. And once I simplify my answer, I'm going to go and get my area in terms of K. And this is my answer. Ladies and gentlemen, I've confirmed this is correct. Let me show you how. If you are wondering what to do, I can show you that I'm going to use my GC. Okay, so what I'm going to do is this. I'm going to go to my GC. Right? This thing will work. Let me switch the sharing. So I'm going to go to my GC. Some of you might be wondering, okay, why do you want to use a GC if let's say there is an unknown constant? And that is why I want you to ask yourself, why did the question prompt you that K is a positive constant? Why did the question prompt you that K is a positive constant? It's because you can just randomly substitute in a positive constant for K into the GC and you can check your answers, right? So, okay, so like what I'm going to do, right, is I'm going to do I'm going to like ensure what I'm doing is correct by using a rough sketch. I'm going to do a rough graph, okay? So what I'm going to do is I'm going to key in the equation of the curve to the GC. So let me go to math. Then this is how you get your modulus out. Then this is x squared times x minus. Okay, in this case, I will try to substitute a small value for k as possible. Smallest as possible so I can avoid careless mistakes, but preferably not 1 because 1 is like very, very generic number. You can just cancel every time. So I'll put k is equals to 2 because it is a positive whole number. So it fits the definition of positive constant as defined by the question. Okay, so what I'm going to do is I'm going to sketch the graph. I'm going to sketch the graph, but I notice, oh, okay, I need to again adjust the zoom settings to make it like easier for you all to see. Okay, so because I'm trying to integrate from 0 to 2k, so my substitute k is equals to 2, 2k is going to be equals to 4. So what I'm going to do is let's say I know that I need to find between 0 to 4. So I'm going to clear this, and what I'm going to do is I'm going to go and change the domain. Then from -3, 5 preferably. Then after that, the minimum value of y, since the modulus function should lie above the x-axis, so I'll just change this limit to, I'll just change this range to maybe preferably -1 lah. And then after that, the maximum, maybe I'll just put 30. Just put 30. And then after that, what I'm going to do is I'm going to press graph. So the moment, ladies and gentlemen, I get out this graph, right? I get this graph, I'm going to go and calculate the integral from 0 to 2k. I can safely do this because I key in the modulus earlier. So we key in integral, right? So it's going to be from, ladies and gentlemen, please remember, for the lower limit, you don't necessarily have to shift the points. You can also key in your desired value of x because you are keying in your customized lower limit. So the customized lower limit I want is x equals to 0. The upper limit is 2k, which is 2 times 2, is going to be equals to 4. So I'm going to keep my x equal to 4, and then I notice that my definite integral is going to be 24 when these are the lower and upper limits respectively. Right. So let me switch back to my PowerPoint slides. Okay, so I hope I'm sharing my PowerPoint slide. Okay. Give me a while. Okay, so back to my PowerPoint slides. Same as I can see here, I substituted k equals to 2. I got the graph out. I got the graph out over here. Then what I should do is that, oh, okay, this is 24, right? So I'm going to check. If I were to substitute k equals 2 into my own working, will I get 24 out as well? And the answer is yes, I did. So, and because I've gotten 24 out, right? That is how I ensured my answer is correct. Okay? So, what is the learning point? Ladies and gentlemen, pay attention to the CSTE, content, skills, techniques, and exam tips. So, the definition of modulus, like I say again, is hardcore content. You will never run away from it if you are taking H2 math. Same thing. Integration technique standard forms. Because if you do not even know what your standard forms are, then how are you going to perform your integration in applications, right? You need a strong foundation in order to go and move on to the more complicated versions, right? Then, of course, the skill. The skill is what I introduced to you earlier. Is to show awareness that the definition of modulus is a piecewise function. Because once you are aware of that, I tell you, it's a guarantee. You can go so far in H2 math just by applying this definition of modulus alone. Then I can solve the inequality, right? It's fx more than 0. When fx more than 0, what is the solution set for x? And after I get the solution set, then only I split into the two parts based on the piecewise function. And this is my technique. Then my exam tips I already mentioned earlier, right? But let me repeat again. Like, do not jump the gun because it's going to result in numerous careless mistakes. It is not worth it. I want you all to get the A. Okay? Then same thing. For definite integrals, right? If let's say you all are going to have careless mistake, a plus minus here, these are called arithmetic errors. It's going to be a painful loss of 2 decimals. So why not avoid it? Try to go and solve the bracket first. No harm doing it, okay? Try to go and put it in bracket first. So don't undo the brackets. Because things like, oh, negative, negative, positive. Negative, positive, negative. People all like forget due to exam stress. Okay. So this is all for question 3. Thank you. Bye bye.